Okay, so we will go to the next test, numerical part for class 9 science, chapter 3, atoms and molecules. I encourage you to sincerely do this. All the sums that are inside the textbook, okay, at the end of the exercise, at the end of the chapter, as well as inside the text, have been solved. So you will find it very useful, and you'll find it quite easy to deal with these numericals if you do the videos. Okay, and in every chapter, whether it is chapter 1 or any chapter, if you follow the sequence video 1, 2, 3 up to 10, whatever the ending video, till the end, you'll find that every portion is being covered. Okay, numerical plus the chapter. Okay, let us start. Question number 1, 3F. So question number 1, we have to do this textbook page. Go to page 45 there. I'll read the question for us. You look there. At point 24 gram of compound of oxygen and boron was found by analysis to contain, so this is a mixture of two compounds, oxygen and boron, was found to contain, this is a compound, not mixture, 0.096 gram of boron and 0.144 gram of oxygen. So calculate the percentage composition of the compound by weight. Now, before you do the main thing, just compare with this example. Okay, example comparison here. Suppose you got 4 out of 10 in a test, okay, class test. Your class test in science, let us say. Okay, and then you got 4 out of 10. So full mark you see here is 10, and you scored your mark, your score. That means your individual mark is 4. Your mark. So the teacher has written 4 by 10. What does this mean? Now you write your mark by total mark and multiply by 100. That is called percentage. Percentage means your mark multiplied to 100. In other words, out of 100, how much would you have gotten? Then you cancel this, then you get 40%. In other words, 40% means it is just like 40. You got 40 out of 100 if the full mark was 100. So that is the meaning of percentage. Keep that in your mind as we do the next one. So here, solution, your answer, since at 0.24 gram of compound of oxygen and boron, okay, oxygen and boron, sorry, was found by analysis to contain, I'm just copying the question, to contain 0.096 gram of boron and 0.144 gram of oxygen, I think. So this is enough for us to calculate the percentage. The next statement says, calculate the percentage composition of the compound by weight. So here, therefore, percentage composition of one of them, let us calculate. Composition of boron, let us say. Any one you can take, boron or oxygen. Percentage composition of the boron in the compound. Okay. Now the total mass by analysis is found to be, boron is 0.096 gram divided by the total mass here of the whole sample, 0.24 gram. So this is like your individual test mark 4, and this is like your total mark, total mass. So if you multiply by 100, then that is called your percentage. Gram cancelled. Now you have here 2 decimal places in denominator. We learn, but before that, this one 100 into this means 0 will multiply and decimal move right. So 1 and 2, so it will come between, from here jumping 1, between 9 and 6. So 9.6 divided by 0.24. 100 has been used up. Now here, you want to remove the decimal because decimal in denominator is harder to deal. So 2 places means you put 2 zeros. So up also same. Then again multiply by this, then 2 places left. So jumping from 6 to the right, 1, 2, divided by this 1, 0, 2, 0, 1, 2. So 24, this much percentage is your percentage composition of boron, your answer. Just a matter of cancelling. 8 3s are 24, 1s are 8, 1 in hand, 16, 8 2s are 16, and 0. 3 4s are 12. So boron percentage is 40%. So the next one is quite easy. Therefore, percentage composition, okay, of the other one, of oxygen, will be, 100 is the total percentage minus this 40. Okay, 40%. That's your answer. 100 minus whatever is boron bracket and that much percentage. So you would imagine that the answer is quite simple now. Percent, and here 60% is oxygen. So oxygen is more in composition compared to boron. So that's your answer. Now let's go to 2. So question number 2, textbook page, listen carefully to this, 45. Let me read the question for us. When 3 gram of 3.0 means 3 gram of carbon is burned in 8 grams of oxygen, 11 gram of carbon dioxide is produced. Okay, what mass of carbon dioxide will be formed when 3 gram of carbon is burned in 50 gram of oxygen? Which law of chemical combination will govern your answer? So your answer or solution. Okay, solution is, according to question, 3 gram combines. So 3 gram of carbon, you can write C, combines because the symbol for carbon is C, combines with 8 gram of oxygen, 8 gram of oxygen to give equal to 3 gram plus 8 combined together, so 11 grams of carbon dioxide. That is what the question told us. So what mass of carbon dioxide will be formed when 3 gram of carbon is burned in 50 gram of oxygen? So second case. So when 3 gram of carbon, that means the same amount again in the second case, is burned in 50 gram, is burned in 50 gram of oxygen air. Okay, your answer is, it will combine only with, and there is a reason for this, it will combine, okay, it will combine with only 8 grams of oxygen, not more than that, not less than that also, because 3 gram exactly combined with 8. So even if you supply extra oxygen, more than 8 also, it cannot consume more than 8 because of the law of definite proportion of compounds. Okay, we'll explain that. So only with 8 gram oxygen to give again exactly the same quantity, 3 plus 8 grams, that is equal to 11 gram of carbon dioxide again. Why is this so? That is, in other words, 11 gram of carbon dioxide. Okay, you can look there into your question, the textbook next page also. 11 gram of carbon dioxide, that is 11 gram of carbon dioxide. So that is your answer. That is 11 gram of carbon dioxide. The remaining, okay, this is the main part of the answer. The remaining oxygen, which is 50 minus 8 is consumed, so 8 gram, which is equal to 42 grams. Okay, the remaining 42 grams is left unreacted. That is interesting. Why we need to answer that? Unreacted. Remain unreacted. This is because of the law of, this is because of the law of constant or definite proportion. Some textbook call it constant proportion, meaning is same, constant proportion of compounds or fixed proportion of compounds. That is your answer. Now let me explain it in a corner. You write it so that you can understand this. Now look at this one. Carbon dioxide is a product. Means carbon is burning with oxygen to form carbon dioxide. Law of chemical combination of constant proportion. I'm going to explain it. One carbon, two oxygen, so it's balanced. Whatever number of atom of carbon on the left, same on the right. Oxygen, whatever is on the left of the arrow, same on the right. This is called law of conservation of mass. So equal number of atoms on both sides. Now look at this one, carbon dioxide, the mass. Okay, let us calculate the mass and you'll find out here. 1 into 1 at the back of carbon 1 and page 37, 12 gram. 1 carbon is 12 U, so we change to gram for mass. Combines with definite, so is 2, right, the ratio language. 2 into here, 1 oxygen on page 37, 16. So this is 12 gram, always combines with 16 to the 32 gram of oxygen. Here, okay, let me modify a little bit. 1 into 12 gram of C. So here 12 gram of C combined with 32 gram of O, oxygen atoms. Fixed proportion law of chemical combination. So this formula is carbon dioxide is always CO2, never CO3 or CO. So that's why it's definite, meaning 12 gram of carbon can combine maximum with 32 gram, not less than or not even more than 32. That is called law of constant proportion. Now you just keep on going. Now just write once more 12 gram of carbon and 32, just to explain your numerical we did just now. 4 is going, 4 3s are 12, 4 8s are 32. See, 3 gram of carbon fixed combined with 8 gram of oxygen. That means 12 gram of carbon combined with 32 gram of oxygen. So proportionately 3 gram will combine with 8 grams. Not more than 8 gram of oxygen, not less. That's why the 42 gram 50 minus 8 is remaining unreacted. When you supply only 3 gram of carbon, it can consume only 8 grams. That's why 42 is remaining unreacted. That is explained by the law of constant proportion here that I explained just now. So write this in a corner of your notebook that you remember, okay? So you'll understand better. Okay, question 2 is done. Now we'll go to question number 7. Question number 7, this will be found on the textbook, page 46. Maybe we can write the question also, then we can see clearly for this one. So 7, question number 7, okay. What is the mass of, okay, so we write here. What is the mass of, question is saying, number 1, first let us deal with one, number A, sorry, they're using A. 1 mole of nitrogen atoms. I'll just exactly write how the question is given. There's nitrogen and they have mentioned atoms. So here, mass mole, that means we have to use this formula. Remember this, you don't need to write this, but for now, for explanation, 1 mole is equal to gram atomic or molecular. If it is molecule, we know that by now. Molecular mass will be equal to Avogadro number 6.022 into 10 to the power 23 atoms, if it's atoms, or molecules, if it is molecule. So now, here we have to find the mass from mole. That means mass from mole. This is the mole. This is 2 part of the formula. You have to find mass. So let us keep the mass that you have to find on the right side. That's normally easier for us. So here, 1 mole, this one, these 2 we're going to use, right? This is mass, mole and mass, mole and mass. So 1 mole of nitrogen atoms, okay, is always equal to 1 mole is always equal to its gram. We say atoms or atomic mass. Now at the back of nitrogen atom means only one atom, so we write one nitrogen atom, which means this one, see, into page 47 nitrogen is 14 U, but we're using gram here, see, gram, so we put your gram, so your answer is 14 gram. 1 mole 14 gram. That's your answer. Then next B, let us write down here. B is saying what is the mass of, continue, B, 4 moles of aluminium atoms. 4 moles of, exactly like the textbook question, only I'm writing aluminium atoms. That's the question. So that is, or best way to start is here we know, or we, even if you don't want to write it, it's okay. So mole and mass is what you have to use. Same formula again, mole and mass. So 1 mole, we have to start with the formula, say 1 mole of, same language, aluminium atoms. And I'll just write the symbol for aluminium for your sake, Al. Aluminium ion means Al3 plus, but aluminium atom, then there is no charge, okay? So that will be equal to its gram, because question clearly mentioned it's atom, so aluminium is an atom, it's gram atomic mass. So at the back of Al only one, so 1 aluminium is given as 27. Right there, 27 also. They are saying with gram, so we put G. So that is 27 gram. 1 mole makes 27 grams. But they are asking for 4 moles. So we write 4 moles of aluminium atoms make equal to this 27 gram multiplied to whatever is here, 4. And we should not bring that mole. Left unit can be brought to the right. Whatever is there, the number can be brought. 4 7s are 28, 2 in hand. 2s are 8, 9, 10. So 108 grams is the mass of 4 moles of aluminium atom. Then the third one, C, okay, C. So C is, what is the mass of 10 moles of sodium sulfate? So this is important, interesting also. 10 moles of, they've written the name also, formula also, sodium sulfite, PHITE, please notice that, Na2SO3, that is the one. So now, again mole from mass, so this same formula, mole and mass. So you write here, 1 mole, and the rest of the language use the same one, of sodium sulfide. They did not mention this time whether it's molecule or atom. So we have to figure it out ourselves. But it's quite easy. Look here. It's equal to its gram atomic or molecular mass. That's what. Now look at the molecule. There are how many atoms here? At the back is the number of atoms, as we said in even previous videos also. 2 sodium atom at the back of S1. So 1 sulfur atom and 3. So this is 6 atoms are there. More than 1 atom is definitely molecule. So it's gram. There are 6 atoms. No, more than 1 is molecule. So gram molecular mass. It's gram molecular mass of sodium sulfide. So we need to calculate that. Anything more than 1. So here at the back of Na, how many sodium atoms in sodium sulfide? It will be shown by the back number, subscript. 2 are there and 1 sodium. Question itself is given there. Not given, but page 37 you go, you'll see that it is 23U. This time we'll change to gram because it's here gram. When we start with new atom, we put plus, right? We have done this before. So sulfur, not this front, back. No number means 1 sulfur atom. And page 37, you'll find it's 32. Then again plus because there is a new. And then here 3 oxygen atom. Page 37 again, 16. You just go and check. So this may as well be written as 2 into 23 plus 1 into 32 plus 3 into 16, this many, is the gram molecular mass of sodium sulfite. Now it's just a matter of calculating. This is 46 plus 1 into 32, 32. 3 into 16, 48. This many grams. So 46, 32, and 4. Add this one, then you get 16, 1 in hand. 12, 126 grams. 1 mole of sodium sulfate weigh 126 grams. It's gram molecular mass. Therefore, they're asking for 10 moles of sodium sulfite. The formula is this same number multiplied to whatever is this number, 10. But we shouldn't bring the mole. Mole is left unit. So that is 1260 grams. It will weigh. So that is the end of question 7. So 1, 2, and 7. That concludes it. Go and do the test 3F. It will be completely identical word for word also. Only thing is number here, 10 moles may become 5 moles during the question. It's quite easy. It's a practice kind of thing. It is fun, okay? You will enjoy it. And if you do that, I guarantee you will be able to do very well in numericals as well as score good marks without trying so hard. Okay, that's it.